Just south of Norris Geyser Basin is a rarely visited thermal area called Monument Geyser Basin. The monuments there are unique in Yellowstone's above-water hydrothermal areas and resemble black smoker deposits found on the ocean floor. Monument Geyser Basin is located west of Gibbon Canyon, south of Gibbon Geyser Basin, and topographically above Beryl Spring. This area is immediately west and outside the boundaries of the Yellowstone caldera. The south-flowing Gibbon River separates the Lava Creek Tuff, which erupted during caldera formation, and younger post-caldera rhyolitic lava flows to the east. The geyser basin occurs above a thick section of the Lava Creek Tuff cut by north-northwest trending faults and cracks. Geyser Basin Monument can be reached by hiking about 1 mile (1.6 kilometers) from the trailhead on the west side of the Gibbon River. The last half of the trail climbs steeply, gaining an elevation of about 800 feet. The elongated geyser basin measures approximately 300 by 100 meters, 984 by 328 feet. And its brownish-white color is the result of hydrothermal alteration of the Lava Creek Tuff covered with sintered silica deposits. Hydrothermal alteration and sinter deposition are caused by an acid-vapor-dominated hydrothermal system. Many small hot springs and steam vents in the area take the form of boiling pools, frying pans, mud pans, sulfur deposits, and fumaroles. The fluid in active springs has a temperature of 71 to 91 degrees Celsius, 160 to 196 degrees Fahrenheit, an acidic pH of 1.1 to 2.5, very low chloride from 0.5 to 3.0 ppm parts per million, and sulfate high from 280 to 4000 ppm. This sulfuric acid liquid comes from steam containing steam, carbon dioxide, and hydrogen sulfide. Its acidity is the product of carbonic acid and the reaction of hydrogen sulfide with oxygen to form sulfuric acid. The area is unique in that it contains about half a dozen constructional sinter deposits, some of which take the form of tall chimneys or spire-like features that are 3 to 13 feet wide at the base and up to 10 feet high. These monuments, from which the basin gets its name, are located along a north-northwest direction, following a regional pattern of faults and rifts. The tall, narrow shape of the sinter tower is unusual compared to most other hydrothermal areas in Yellowstone. Although it bears some resemblance to hydrothermal towers found at the bottom of northern Yellowstone Lake. Its shape suggests that a glacially dammed lake or pond may have existed during its formation. Undersea vents of buoyant hydrothermal fluids that precipitate silica can create tall structures similar to sulfide chimney deposits known as black smokers that develop from hydrothermal vents on the deep ocean floor. Another unique feature of Monument Geyser Basin is that it covers a larger hydrothermal system along a northwest trending fault or fissure that cuts through the hillsides down to the Beryl Springs area along the Gibbon River, providing a three-dimensional view of the hydrothermal system. Beryl Spring is a powerful and active alkali chloride hot spring pool, considered one of the hotter and deeper-sourced hydrothermal systems in Yellowstone based on its boiling temperature, high chloride content of approximately 500 ppm, and pH range of 6.5 to 7.0. Studies of helium isotopes and the abundance of carbon dioxide in the fluid support a deep origin. The approximate temperature for this type of fluid at depth is 350 to 400 degrees Celsius. Beryl Spring is also directly associated with steam-dominated steam vents, one of which occurs directly behind the main pool, evidence of complex hydrothermal piping that can produce vents with very different chemistry occurring next to each other. Hot springs at depths like Beryl usually boil due to a drop in pressure as the liquid rises to the surface. Boiling releases steam mixed with volatile gases, mainly carbon dioxide and hydrogen sulfide. Additional steam-dominated ventilation occurs near Beryl Springs and as springs along the Gibbon River, including problematic ventilation under roads adjacent to Beryl Springs. Nearby, to the northwest, there are hot springs with a mixture of high chloride liquid and predominantly steam. This low-density buoyant vapor has risen along a northwest trending fault through a thick section of the Lava Creek Tuff, forming the steam-dominated Monument Geyser Basin. As steam reaches the surface at Monument Geyser Basin, cooling causes the steam to condense, and carbon dioxide and hydrogen sulfide are absorbed into the hot fluid, both of which contribute to the strong acidity observed in the thermal region. Hot acidic fluids intensely alter the high silica content of the Lava Creek Tuff, dissolving silica that precipitates back as sinter and creating altered silica peaks and white areas that serve as a cover for rising steam. The result is a steam-dominated zone beneath the Monument Geyser Basin with low levels of hydrochloric acid in this stunning area.